All right, so this is a very chemistry thing for us to do. In the very last lesson, we tell you that everything we've shown you is a lie. um, Sorry about this. When you're doing an ice table of this kind, if we did it the right way every time with the minus x that is shown in the lesson, you would end up having to solve a quadratic with ugly numbers in it, and we cannot assume that all of you know how to do that. They used to, and you'll notice the quadratic formula is actually still in the data book because they used to. But we no longer make people do these ice tables because the number crunch is just too painful. But we want you at least to know when you can trust your results and when you should be using an ice table or brushing up on your quadratic formula skills. So the way you check is you're given an acid and its concentration. You first look up the acid constant for whatever your acid is. So benzoic acid, you go to page 8-9 in the data book, you locate benzoic acid, which is at the very top of page 2, and its acid constant is 6.3 times 10 to the minus 5. You multiply that number by 1,000, which gives you 6.3 times 10 to the minus 2, or 0.063. This is your cutoff. If the acid is stronger than this number, then using the formula is okay. So if the concentration of the acid is bigger, it means the formula is okay. If it's smaller than that number, then you'd have to go ice table. So in this case, 1 is bigger than 0.063, which means you could safely use the formula for this benzoic acid solution. Okay, here they did not give us a concentration because they're jerks, and by they I mean me. The concentration here is number of moles of methanoic acid divided by volume, 0.2 moles divided by 1.3 liters. 0.2 divided by 1.3 is 0.15 should be enough. 0.15 moles per liter is how much methanoic acid we actually have. Look up methanoic acid, also known as formic acid, in your data book, and where is it? Ka is 1.8 times 10 to the minus 4. Multiply that by 1,000. Pro tip, that just brings the exponent up. Oh boy, sorry. I'm so used to writing the ion product for water that I just automatically put a 14 there. That is negative 4. Okay, pro tip, multiplying by 1,000 just raises this power by 3 because 1,000 is 10 to the third power. So you're going to get 1.8 times 10 to the minus 1 here, or 0.18 moles per liter. So this is the minimum volume. If the acid is more than this, we're safe to use the formula. If it's less, we have to go ice table, and it's very close, but this concentration is lower than the cutoff. That means the formula will give you pretty skewed results, and you are better off going ice table for this one. You can expect significant error if you just use the formula. Okay, hydrofluoric acid, they gave us the concentration, lovely. And HF has a acid constant of 6.3 times 10 to the minus 4. Multiply that by 1,000 and you get 6.3 times 10 to the minus 1, or 0.63 moles per liter. That's our cutoff. If we're stronger than that, we can use the formula, and hooray, we are. The solution's strong enough that we don't need to go to an ice table. 2 grams of HCN. We need a concentration. We don't even have a number of moles, so they're making us do all the work in this one. Number of moles is mass over molar mass. Okay, 2 grams. Molar mass. 1201 plus 1401 is 2602. Add another 1 and you get 2703. I hope I did all that right. If not, you get to taunt me mercilessly in the YouTube comments. All right. Number of moles, I get 0.074 is probably enough. That's moles of hydrocyanic acid. And our concentration is that number of mole divided by 0.15 liters. 0.49 moles per liter is what we actually have. What's our cutoff? Hydrocyanic acid is about 2/3 of the way down the second page. Its acid constant is 6.2 times 10 to the minus 10. Multiply by 1,000 and you get 6.2 times 10 to the minus 7, or 0.000000062. This concentration is way more than that, so the formula is totally fine for this one. And finally, hypochlorous acid, they gave us the concentration, awesome. And hypochlorous acid is 4 times 10 to the minus 8 for acid constant. 4.0 times 10 to the negative 8. Multiply that by 1,000 and we get that the cutoff is 4 times 10 to the minus 5. The cutoff is 4 times 10 to the minus 5. This concentration is only 1 times 10 to the minus 5. It's too low. This is not enough for us to use the approximation. We'd have to go ice table for this one. Hope that's good. As usual, if it didn't feel good to you, get a hold of your instructor. We are happy to help. Take care.